So this is Kinect 101. It's an introduction to Kinect for Windows. I'm Chris White. I'm a senior program manager on the Kinect for Windows engineering team. So today we're going to go through a set of things. We're going to start out with just a quick introduction to what is Kinect, physically what is it, what are the different pieces in it, talk through a little bit of the history, go through some of the interesting ways that it's being used across a number of different industries. We're going to spend a lot of time in demos and also seeing a set of pretty cool videos. Then we're going to dive into the core concepts and actually see more demos around each concept that really bring them clearer, and then finally link out to some resources. So what is Kinect? Fundamentally, the reason Kinect is cool is that it's this new kind of camera which can see in 3 dimensions. So for every pixel, it can tell you how far away in space that is. It also has a traditional video camera, a 4-element microphone array that lets us listen preferentially in different directions based in software so that we can actually pick out different noises in a room. And then there's a powerful SDK which can do a lot of interesting things. We'll be walking through some of those things today. First, I want to echo some news which has happened over the course of the day. First one, Kinect for Windows V2 sensor, which we'll be looking at today, is coming this summer, along with full supported SDK. And for the first time, you're going to be able to create and publish Windows Store applications which leverage Kinect. So this is something we're very, very excited about. We're also working closely with Unity to get a plugin into Unity, which gives you a nice native Kinect support, which will be consistent across Windows Store, Windows desktop applications, and eventually Xbox applications as well. So it'll be a write once, target many platform story. So the talks that we have today and over the course of this week, the first one, if you're wondering where you are, this is it, Kinect 101, Introduction to Kinect for Windows. Tomorrow, Kevin will be giving a talk bringing Kinect into your Windows Store app. The talk today is going to focus, as I said, very much on the concepts and the high-level details. Kevin's talk is going to go in detail into the code in how to actually write Kinect applications, including the work to sort of plummet through into Windows Store. Another talk that we want to call out is building Windows, Windows Phone, and Xbox One apps. So this talk already happened, but it's going to go through all of the basics of actually building these apps. Kevin's talks will be very focused on the Kinect components, the Kinect aspects. This is a good pair to it, so if you haven't seen this, I recommend you watch it as it becomes available on streaming. So a little bit about history. So you are the controller. In 2010, we launched Kinect and had the honor of becoming the fastest selling consumer electronics device in history, actually certified by Guinness. Fundamentally, at the time, it was all about building amazing games and amazing experiences in Xbox. So things that are in the shell that weren't there before, and games like Dance Central or Kinect Sports that actually engage your full body. Pretty quickly, though, people got really interested in the fact that there was suddenly this new computing capability. And the initial interest that people had was really focused into sort of the hacker, researcher, artist community. People saw that there was this new potential and got really, really excited. One of my favorite projects is a project I saw a number of years ago that's still getting better year over year called Space Palette. So I wanted to take a second and actually play a video and have Tim, the guy who built it, walk through.
So this is the Space Palette. Each of the 4 big holes is where you play just by waving your hands. In addition to being a 2-octave keyboard musically, it's also a 3-dimensional mouse pad like you're finger painting, and that's what's producing the graphics that you see. Each of the big holes is a separate sound and a separate shape. And you see the further in, it's all 3-dimensional because of the Kinect camera. It's able to tell me how far away the hands are. Any number of hands will work. And then the little holes are like buttons that let you change the sounds and the graphics.
So it's a fun, simple example of somebody who, because he could now actually track that there's a person there, track where their hands are in detail, could actually build this object that was an art object that he'd never been able to build before. So anytime you run into that kind of enthusiasm, you have choices. You can kind of ignore it, you can hope it goes well, you can really lean into it. And so in our case, we're actually really excited about all of these things, so we've done a lot of work to go lean into it. The most recent thing is some work with open frameworks to build something called Kinect Common Bridge. So the idea was to take dead simple integration of the Kinect capabilities into the tools that a lot of these artists use. It's worth calling out that the V2 sensor is going to work in this space, and we're working closely with them to make that happen. Have one more cool video of a set of things which demonstrate what Open Frameworks does, what these artists are using this to create. So in addition to capturing the imaginations of all of this initial community, these artists, researchers, hackers who want to do things that they couldn't do before, it started to really capture the imaginations of business. And again, this is something that we are really interested in encouraging as Microsoft. So we launched the Kinect for Windows SDK. It included hardware that was actually built to plug into a Windows machine as opposed to built to plug into an Xbox, a full SDK to give access to all of the software capabilities that we'd exposed into Xbox, and a full commercial license so that you could do absolutely anything with it that you want. We've had 5 releases of the SDK starting in February 2012, so we've had a very, very fast movement within the team and close engagement with the community, listening to what people really want and trying to bring those things to them. And we've had around 1 million cumulative downloads. So that is a tremendous number of people who have started out and started to experiment and build applications, in many cases build real applications that are starting to be used in industry. Early on, we ran an accelerator program. So this was where we were looking for early stage companies that were trying to bet their business on Kinect. We were expecting about 100 applications. We had roughly 500 applications. So blown away by the level of interest and excitement. We've been blown away again in the V2 developer preview program that we've run at the number of people and the level of interest that we've had in it. And finally, there is already traction across a broad range of industries. So getting into the details of how Kinect is actually being used in businesses today. So we tend to think about these in segments. So the first segment that I'll talk about is retail. This is actually an application, a screenshot of an application called Swivel by a company called FaceCake, which is basically a virtual try-on. So as you walk up to the mirror, it actually puts augmented reality clothes on you, lets you sort through the set of things that are available in store, take pictures of yourself, and it's a way to discover the inventory of the store without having to do that high transactional cost thing of going into the dressing room. And retail is really deep. So this is virtual dressing rooms at one level. There's another set of companies that are doing in dressing room full experiences where they're using the Kinect to actually scan your body in detail and tell you which size of which brand of jeans that's in stock at the store right now will fit you and how it will fit you. There are all kinds of immersive kiosks that are being built. One of my favorite examples is car companies. So it turns out cars are really, really big, and it's hard to put a lot of them someplace like a mall. But car companies would like to sell cars in malls. And so they're building these stand-up, pop-up kiosks where you actually get to see the car, look at it from different directions, experience it in this new way that doesn't actually require the car to physically be there. There are a lot of interactive window displays. A lot of this stuff is really brand extension stuff. Jay-Z did a cool Jay-Z Gold thing in New York City. And then finally, analytics. And there's a lot of traction in this space. When you think about online retailers, people have become really spoiled. They have all of this information about people, about what they looked at, how long they looked at it. If you looked at this thing, what did you end up buying? And it's something that traditional brick and mortar retailers have historically not really had. So there are a lot of people building solutions that actually instrument the real world using Kinect to look at what objects people are picking up off of shelves, how long they're holding them, are they actually buying them, what areas of the store get the most movement. And I'm not going to go as deep into every one of the other industries because it would take us a long time and I want to get to the actual demos and looking at the tech. But at a high level, physical therapy is an area where we're seeing a lot of traction. We have a company called Reflection, which is here with us today. People who are waving right now. They actually have their solution down in the Kinect for Windows booth, and I encourage everybody to come stop by and check it out. It's actually very, very cool. We have people who are going into other healthcare areas as well. So this is a fall prevention application that's following a already approved protocol for getting people to be more stable, to not fall down, and really improve elderly care. This is a shot from Siemens, and they've done integration into some of their manufacturing software. It's one of the most valued and excited additions to their software that they've seen in a long time. Massive level of interest in the community. And then we also have a bunch of work going on in education and human simulation and training. This is a shot of Kaplan Early Learning. And so this is a series of games focused on reading that are distributed ultimately over Windows. So we're going to take a look at one more video. This one is sort of an amalgamation of some of the ones that we've seen before, but I'm going to walk through some of the things that we see in it to introduce some of the ideas. In the back, for this one, if you could keep the audio on the PC down and keep my voice going, I'd appreciate it. Okay, so it's a normal retail environment. Person's walking around. And there you'll see the system saw them. It did some augmented reality stuff, but they didn't choose to engage. Now this person is actually stopping and engaging. Again, we're seeing the augmented reality. Here are new clothes. They actually lift their hand, indicating to the system that they want to work with it. And now they're able to work through and select things. So that, if voice was on, you would have heard her speak to the system and say, show me skirts. And then here she's targeting. She's selecting something, and that thing is switched back onto her. And because it's able to track movement in detail, you're able to do these nice synthetic renderings using the information that's actually coming from the sensor. So once again, grip to select, able to do effectively remote control of the system. Find something that she actually likes. So now she's saying she wants to take a screenshot, and she's able to composite a different background. We see a lot of people doing these kinds of green screening without a green screen solutions, where because we understand which pixels belong to you, we're able to actually separate them out and make it easy to do these nice matte composites. You can do that with different backgrounds. And then almost all of these kiosks that we see people building have some kind of takeaway. In lots of cases, it's actually a transaction. Somebody connects to a sales associate, and then that becomes easy to make a facilitated transaction. In some cases, it's a social takeaway. I have a picture, now I can go share it with my friends, things like that. So quick recap. There we saw an immersive kiosk. We saw the interaction model. We'll talk about this in much more detail later. Analytics was actually going on in the background. So the store knows, hey, it was a woman who came up. She worked in front of it for this long. These are the different clothes that they tried out. This was the path that they took through it. And it was a good example of augmented reality with virtual fitting for shopping. Pardon? Yes, there are partners who are building analytics software that do that distinction to some degree of accuracy. And that's one where you actually want to be really careful how you use those guesses. The top numbers I've seen are up around 90-95%, which is good enough for analytics, but maybe is not good enough to shift everything to pink if you want it to be blue and vice versa, because people get are surprisingly touchy when you get their sex wrong. All right, so demos and core concepts. So as mentioned at the beginning, the Kinect is a composite sensor. And initially, we're going to talk through what we think of as the eyes and ears. So think about this as measurements we're taking about the real world that are effectively coming off the sensor. So the 4 of them are depth, color, infrared, and audio. And we'll talk through most of these in a lot more detail in a moment. So now we get to see if the magic dance that we did before is still working. We need our top men back. So while they're working on this, are there any questions? I'm happy to answer anything that's come up so far. Yeah, so the V2 sensor for Kinect for Windows will also have a USB adapter. It's USB 3 because of the amount of data that's coming off, but it will be tested to work with a broad range of USB 3 controllers. Well, they have a common set of shared technology underneath them. The Kinect for Windows sensor is built to actually function with a PC. So the Xbox is, for instance, has a very specific controller and understands exactly that it's a Kinect that's talking to it. Whereas when you plug into a Windows machine, you need to work across a broad range of controllers. And they actually need to follow all of the USB protocol things, which we don't necessarily need to do when we're inside the context of a fixed system. Yeah.
Concept of adding this to be web-based also, so that you go to web-based Kinect enables?
It is something that we're definitely interested in. Within the context of Xbox, we've actually built in Kinect enablement to the browser itself and sort of core to the operating system. So you see the beginnings of that. Also in Kinect for Windows 1.8, we did a fair amount of work so that people who have experience in web-based programs and programming wanted to leverage that skill set could actually build on top of HTML5 in a browser. Hey! Okay. So that people could leverage their HTML5 skills or whatever tools they have that exist in web space. That was still not a Kinect-enabled website. It was a local machine that was a kiosk. All right, so we now actually have the ability to see the screen, which is good. Although some of the apps are gone now. Give me one moment. All right, so the first core concept, and I want to give people a heads up. We have a set of slides on this. My intention had been to go back and forth between, hey, here's this, we'll go back through the points. Right now, every time I switch these, everything breaks. So we're actually going to spend a bunch of time in demo, just walk through them, and then we'll come back to the slides and the bullet points afterwards. So the first sort of core capability that Kinect brings that wasn't there before is what we call depth. So it's basically for each pixel, how far away is that point in space? On the left-hand side, you're seeing the depth signal coming off of the original Kinect camera. On the right-hand side, you're seeing the signal coming off of the Kinect V2 camera. So immediately you'll see that there's a significant change in the level of fidelity that's available there. So there's roughly 3 times the depth fidelity that was in the V1 sensor. There's also a significantly lower noise floor. So as an example here, on the old sensor, you see my hand basically disappears into my shirt. On the new sensor, you can see it still stand out clearly. The other thing, when you look at the old sensor, you can see there's a person there. You can see they're wearing a hat even, but you don't pick out the individual facial features and stuff like that. Here, you actually see all of the folds in my shirt and the little detail. So anything that you're doing that was leveraging depth is going to be more powerful in the new case. A question? Let's hold that for the end, please. So increased fidelity. There's also a significantly increased field of view. I actually only have so much space up here, but let's see how far back I can go. So here you can see the sensor can actually see me still with the new sensor, whereas I'm further away from the, or further out than the old sensor can actually see. It also has increased field of view this way and this way, which means that as I get closer, more of my body stays in frame. This matters a lot for all kinds of public installations that people are doing, because one of the biggest problems, it used to be that you stayed about this far away from the sensor, and this far away from something, there's no social cue that says it's not appropriate to walk between me and that space, which would actually break up experiences. Being closer makes it much easier to build these experiences in public places. Let's actually hold some questions to the end. All right, so let me actually close, no, before I close that guy, 1 second. All right, so here I'm going to take this and point this out towards the audience for a second. So congratulations, guys, you're on film, sort of. Now, the thing I want people to get is that this really is a three-dimensional view, so it's almost like a point cloud. So I can actually go and reconstruct different perspectives on it. So it's easy when you're looking at just the straight-on depth view to say, oh, that looks a lot like a normal camera. But in point of fact, it's adding this important three-dimensional data to what you're capturing. Go ahead and close that guy. All right, so the next capability that we'll talk about is infrared. So people are relatively familiar with the idea of an infrared camera. It's something that can see in a different range of light than is our normal visible light. This is actually not exactly that. This is a special kind of camera, and it's basically a synthetic view where we're seeing only the light that our camera actually emitted. So we're only seeing the light that was from the laser. All of the light that's from these spots and stuff, which are putting out a ton of infrared, I promise it's very hot up here, are being actively subtracted out of the image. So as I'm moving around, you're not seeing variation in the lighting on this image. Now, for anybody who's tried to do any kind of computer vision or machine learning based thing, I know that lighting variation is actually a really hard problem. We get deep shadows on our faces as we move from sort of one side to the other, and that makes it really hard to look for things that are features of the object as opposed to these artificial features because of the lighting that's happening. So this is a really interesting, new, powerful capability. We're super excited to see what people do with it. The other one, and we're a little cut off on the edge here, part of the same screen problems, is that there's a full, beautiful 1080p color camera, runs at 30 hertz. It's been absolutely amazing to see the difference this has made for our partners' applications. People who ported up to the V2 sensor, even if they didn't make any intentional changes to their application, if they had any of those augmented reality kinds of solutions, the level of quality, the perceived level of quality in the applications went up by orders of magnitude simply because of how much better and more compelling the video was. It also is a nice wide-angle lens, so you can cover a very, very large area with it. One other fun note, just going back to depth. So we actually had partners who were storing all of the depth data because they were doing something like medical imaging and they wanted to, or physical therapy, and they wanted to store the base data so they could go back and compare later. And they didn't have to worry about anonymizing the data because it turned out it was not really possible to tell what people looked like. The new data, when they've gone to the V2 sensor, they've suddenly had to start worrying about cutting out people's heads because it was so easy to tell that this was actually this person. All right, so we've talked through basically the eyes and ears, the things that are sort of core information that are coming in. Now we're going to start getting into the brains. So this is skeletal tracking. We're basically identifying, hey, there's a person here. There's actually a body there. And further, I understand what pose they're in, where their joints are. There are a set of differences between this and what we had offered in V1. The first thing you'll notice if you did any work with V1 is that the joints are much, much, much more stable. It's going to be much easier to write applications that are leveraging joint positions because the combination of the enhanced fidelity from the depth sensor and all of the improvements that we've had in software lead to a much more stable skeleton. The other thing you'll notice is it looks actually a lot more like a person than our skeletons from V1. So we've strove for anatomical correctness. Shoulders are really where shoulders are. The hips are really where the hips are. And we're able to pick out these fine-grained motions that like moving my shoulders or tilting my head that would have been very hard to pick up in V1. You'll also notice there are these little lights that are popping around my hands. So this is a hand state tracker. So for instance, green is saying open hand, red is closed hand, and then this is a signal that we call lasso. So these are building blocks that are just there in the SDK. We actually use them in our interactions work, and we'll go through some of that. But it also is just a component that it's easy for other people to build up things on top of, and we've seen a lot of interesting things that people are doing. In V1, we could track up to 2 skeletons. We could see there are 6 people there, but we'd only give you 2 skeletons at a time. We now give skeletons for all 6 people in the field of view. The other change that we've done is we've gone from 20 to 25 joints in the body. And the most important differences are actually the hands. So it used to be that you got a single point for your hand. Now, in addition to that point that's telling you where the hand is, you're getting where the thumb is and where the tip of the hand is. And the big thing that gets you is you can understand this kind of motion very easily. So when you're trying to do something like avateering, so you're trying to rig a model and bring them into a virtual world, actually understanding what people are doing with their hands is very, very important. It's a big part of whether people connect to the model and think, hey, that's me, because it's actually tracking my motion. So as part of that, we have a fun little guy named Boxman. And this is just basically taking those orientations. We've worked out all of the orientations and exposed them in the SDK in a way that makes it really, really easy to rig these 3D models. And so it's able to actually see everything that I'm doing and track movements where I'm actually twisting through space as well as just sort of straight position in the world. In the interest of not switching back and forth, I'm going to find my last demo and go ahead and do it now. So this one's actually very exciting. I mentioned up at the top that for the first time we were going to be able to build Windows Store applications. And so we have our first example of a prototype Windows Store application here that was actually demoed in the keynote. So this is, in the keynote, this was used as an example of an application that's able to be published to Windows Phone, to Windows Store, and to Xbox as well. And they showed off some of the Kinect integration in Xbox, but for the first time, we're also able to do Kinect interaction within the context of the Windows Store. So the first thing that happened, I lift my hand and engagement happens. So this is how I'm telling the system I want to actually work with you. And so that's the first point that we see the Kinect cursor. This is a much simplified engagement model over what we had done before. Our tracking has gotten so much better that we're able to avoid incidental and accidental activation much more easily than we were. And so we've been able to remove speed bumps and make it a really, really simple thing. Second thing to notice is that the hand that's up there is a right hand, just like my hand. So we're actually able to see and identify the difference between the hands. So now if I'm left-handed, I get the left hand up on the screen. The second thing to see is that a relatively small space in front of me maps to the entire screen. So this is something we call the physical interaction zone. It's a space which we've experimented with and is based on my actual body geometry, or the body geometry of the user. So that it's a space that is adapted directly to you, that you can keep your hand up and in for a reasonably long period of time without actually getting tired. It ends up being very close to the space that people use for sign language for that same reason. So the other interactions that we have as core built-in things, the first one is scroll. And so I can just grip and scroll and have exactly the same model that I have in the world of touch. And if this was vertical scrolling, I could do vertical scrolling as well. And then for selection, I just push. And actually mute my guy. And so we have all of the core interactions as things that become available in Windows Store. And what's very, very nice is it's exactly the same set of models and assets that are being used in Xbox. And so everybody who is learning to interact with the computer this way through Xbox is being trained to use this model. So we end up with an awesome built-in user base. All right, so we're going to come back through and re-hit a bunch of the points. We're out of demo land now, and so hopefully we don't need to switch back and forth anymore, because that was terrifying. OK, so depth and depth maps, fundamentally, it's asking how far away is each point or each pixel. It's a camera that sees in 3 dimensions. The V2 sensor has significantly increased field of view. We can see more space and see a larger area. We also get more depth fidelity. Normally, there's this trade-off. As you increase field of view, you actually are getting less data per pixel because it's covering a larger arc length. In this case, the underlying improvement in the technology that we're using to actually capture depth so outweighs that you get best of both worlds. You get a larger area, but you also get significantly improved fidelity. And as mentioned, you get the lowest noise floor. So color is a traditional camera, except we have our own set of APIs around it so that you can go back and forth between the spaces. I'll talk about that in a second. It's full 1080p video, which if you're building something today is what you want. And it's full 30 frames per second. It's also consumable in multiple formats. There's always one format that's streaming off the device, but we have a set of helper functions to do conversions for you. So infrared, as mentioned, it's able to see in the dark, and it's only showing you the light that it emitted. This is actually in strong contrast to the infrared capability we had in the V1 camera. In V1, we were actually shooting out a range of little speckled dots that we were looking for. And so although you could pull infrared off it, you were getting this dotty infrared based on the lasers that we had. In the current camera, we're actually sending out a complete clean light field, and so we're able to get a nice, clean infrared signal. And we can run it at the same time as color. So there are these different sensors within the actual device, right? There's one camera for the color camera, and there's one camera for depth and IR that we're getting the data out of. So if you think about it, each of them has a distinct view frustum. And each pixel basically represents a ray which is shooting out from the camera. But one of the most common things, so they don't have the same coordinate system. One of the most common things you want to do is understand, hey, for that point out there, what color is it? So that I can actually pull together those 2 signals. Or likewise, for that color point, how far away is it? And so we have a set of APIs that make that easy for you as well. Demo, now we would do the other part of the demo. So we tend to think about Kinect as eyes and ears and brains, as I mentioned in the demo. The eyes and ears is the access to raw sensor data. What are extrinsic measurements of the world that we're able to take? And we think of the brains as the higher level understanding. And over time, the offerings in the brains area is going to get stronger and stronger and stronger. The first core one is body mask, or body index. So it's asking the question, for every pixel that I can see, is it part of a person? And if so, which of the people that I'm currently tracking is it a part of? So they're rendered as color here. It's basically a 3-bit field which is telling you which of the potential skeletons it is. For body or skeletal tracking, as it was traditionally known, there's improved reliability and accuracy, more reliable lock-on, and more stable joints. The joints are actually in the right positions. 6 players tracked at all times, and that also makes the engagement stuff within the context of interactions easier. And we've added a series of joints, and orientation makes the animation stuff easier. I have hand states, 3 that we're tracking, so open, closed, and lasso. And we track hand states for up to 2 people at a time. So you still do have some choices in the API about where you're targeting your sort of area of interest. And I'm actually not going to talk through the interaction stuff in detail. At high level, there was engagement. Engagement is really simple. I raise my hand. I think this guy's actually a video. Hey, he raises his hand. Targeting, how I identify what on the screen I'm actually interested in. Activation, so actual press detection. And then panning or movement. We mentioned the physical interaction zone, space in front of you. It's a curved space based on your arm position and length, easy to keep your hand up, and it basically maps the XYZ of your hand to an XY position on screen. Press detection, so the goal is very natural pressing, and it turns out that that's non-trivial because everybody does this a little bit differently. When we started doing the learning around this, it was actually this weird shift in mindset that we had to do because we'd built it and it worked really well for all the people on the team, and then you'd bring in a bunch of people who've never played with a Kinect before, and they start pressing like this or like this, and the immediate reaction you have is, you're doing it wrong. And it's like, oh, no, wait, we're doing it wrong. The goal is that however you do it, it actually function. And so there's a lot of work we've done around basically once you've targeted towards something, if you start the press motion, pulling the actual cursor position that we're showing up on screen towards the center of the object that you're pushing into. And we've also separated out sort of logical space versus physical space. So if you have something like a back button that's a small button up in a corner, you can actually define a large area that is an area of success. And that gravity that we have basically defines a really large cone of success where you can push and actually get activation to work. And there's always active feedback. A subtle thing I should have called out during the demo is as I was pushing, my hand is actually filling up. So the translucency is changing. So you're actually getting feedback letting you know how close you are to activation of the object. Panning. So the goal, absolutely everybody understands how to pan with touch, and so we wanted to leverage that learning, not make people learn a new model. So we actually have 3-dimensional panning now. This is slightly wrong, so it's scrolling 1, 2, or 3 dimensions. So it's 1 or 2 or actually 3. So you can pull something towards you or push it away from you if you choose to set that up. And it's this very tight physical mapping. So it's hard to communicate without using it, but the feeling of connectedness to this thing that you're not actually touching is absolutely amazing. So, finally, what are you guys going to build? We're really, really excited about this technology. We're blown away by the level of interest that we've had already, by the things that people are already building, but we know we're just at the beginning of this journey. And so feedback, questions. So now this is your time for questions. And I got told to ask people who have questions to come up to the actual mic so that people who are hearing it on livecast later can hear them. So I apologize for those of you who have to now navigate from the middles of your seats.
One of the questions I had was, you talked about the lower noise floor. And one of the things that I noticed with the old Kinect, I'd done a little development with it. I was tracking a robot on the floor. I had to like manually account for about a 5% variation in just frame to frame measuring the same pixel, even on a static object that didn't move. Like you could see in your shirt when it showed the demo, like you were waving a little bit.
Yep.
What are those values down to, and do you guys have any feel for that? Or
it is significantly better. I don't know the absolute number. I've seen it be, like my guesstimate, roughly 5 times lower, but that's not an exact measurement. That's my observation. No, that's okay. I'll reiterate your question.
Okay, we're looking at using the Kinect sensor in home automation. People who are handicapped, when they come up to the door, it recognizes them and opens up. Now, on the Xbox One, when you stand in front of it, it says, "Hello, Kurt," and it logs you in right away. Now, is that same software available to us to do where we can utilize it so if someone walks up and recognizes them, they'll open the door, or is Microsoft using that proprietary for the rest of the world?
So the question is, there's identity technology in Xbox. Is Microsoft going to open that up? And the specific context was, hey, could we use this to actually allow entry into a home? The identity tech that we have in Xbox is fabulous for figuring out when you want to log into Xbox Live between the set of people who are in a home. So it's targeted at a relatively low number of people in a space, and the risk, if you get it wrong, is not that burglar comes into your house. So that tech is probably not applicable in that scenario.
Talked about is like, for example, they get to, they're on the inside and the door can actually open up and they go outside to the garage.
So if you're just trying to see there's a person there, and to allow sort of inside home access once you're already past an authentication barrier, then actually just the straight skeletal tracking will be sufficient. It will identify there is a person there, and it is easy to add some heuristics on top of that if you want to. The specifics of the identity tech, we're still working out our plan for which of those components make sense in context outside of Xbox, and what's the right roadmap there.
Is it possible to do anything higher than 30 frames per second in any resolution, or not currently?
So the question was, can we go faster than 30 if we make trade-offs against resolution? Not currently. It is something we're interested in, but have no plans about at this time.
Yes. If you have multiple Kinects covering the same area, what level of interference should we expect from that?
I don't know the right way to characterize it. Generally, it will be, they don't tend to interfere, but when they do, you get bad depth frames. So the randomness of the clock jitter that you'll get on the individual devices will tend to keep them out of phase and not interfering with each other. They're actually very small time slices that you have where the light is actually active. But if you do hit one of those collisions, then you'll get a corrupt depth frame, probably from both cameras. We're still working through, there may be more advanced things that we can do to make that story work well, and it's something we're definitely interested in.
So one of the two questions, one is, will this come to mobile devices and will this be part of Cortana? And the second question is, a slide you skipped it, so it showed how to get it.
Yeah, the reason I skipped it is actually because I'll get you the information. It didn't actually have it. So this is probably not going to happen. But certainly, I think that depth technology will come to cameras. It will come to phones, and it seems to be a direction that things are heading. I don't have any plans to announce it at this time, but it seems like something that will happen.
You don't plug the one that we're getting from our Xbox One and plug it into our PC.
Oh yeah, so the question was, can you take one of these that is an Xbox One and plug it into your PC? And the problem comes with this guy. So this is not actually a true USB compliant device, and it has a custom connector that is sending both power at much higher than the USB power signal allows, and all of the signal back and forth. So this is a hub that actually brings the core tech here into USB compliance, makes sure it's not going to kick off all of the other things on your PC or fry your PC, and provides power going to the system because you can't get that amount of power off of USB. Yeah. I don't know of any plans to buy the little box.
Do you have a BOM, a bill of materials, and on the components in the Kinect?
I don't think we tend to publish bombs. I've certainly not. Do you mean, sorry, do you mean like the set of components that are inside of this device, or do you mean the set of objects that are inside the box?
The set of devices inside.
Yeah, I don't believe we publish those. I'm unaware of us doing so in other contexts. So I think the question is, are there components or bits available for download for you to be able to play around with the system? Yeah, so we have a full toolkit and SDK, which are available freely for download for work with this guy. And when this hits public availability, we will also have a set of components and SDK freely available for download this summer. So the question was, when does this guy become available? And the answer is this summer.
Can you talk about your plans for software support and feature sets being added to the SDK? There was a lot of work done over the lifetime of the Kinect V1, and I just wanted to hear if you were able to say anything about your plans for support going forward for the Kinect V2.
Yeah, we expect to be doing relatively frequent updates to the SDK. We're at the birth of this very new space. And the work that we're doing right now is the core work to get up the capabilities that we've shipped before in different contexts and get those exposed to people in the V2 sensor. Over time, we're absolutely going to extend and add capabilities. The thing that will drive us is, what are the most interesting scenarios? Where are the cases where there's some piece of hard technology where if only we could do this one thing, then it would light up all of these new really interesting scenarios. And I would love to hear anybody's ideas around that. One more time? Yeah, there are some slight improvements to the microarray, but they're relatively modest. They're not the same scope of change because microphones are this very well understood, well established tech. And so the core microphones themselves have improved a little bit. Their orientation has changed a little bit. We've done optimization around beamforming, so those algorithms are a little bit stronger. So there are a series of small incremental improvements there, but the real change that we're seeing is in the depth tech, which is much younger technology.
How much computation is being done in the camera as opposed to in software?
Excuse me. We do heavy computation in software. The main computation for the software is actually being offloaded to the GPU, running in direct compute shaders. So it's really raw signal that's coming off of this. Skeletal tracking, the generation of depth, the generation of IR are actually computed signals on top of that are running in the GPU. It isn't at this time. It's oh, sorry. Thank you, Ben. The question was, is the app that I was showing part of the SDK? Each of the little components, or most of the little components, are available, but that whole together app isn't yet. We're interested in doing so at some point, but it's really just something we built for demos. But it was a reasonably quick app for us to build.
Yes. Can you track multiple audio sources or speech streams at the same time?
It is, I don't think so at this time. We point a single beam, and so we're only doing audio recognition in one direction. It is absolutely something I'm interested in adding over time. So right now, the SDK only exposes, oh, sure, sorry. The question was, what's the depth range of Kinect V2? Right now, the depth that we're returning is clamped at 4.5 meters, so just under 5 meters. We're exploring what it would look like to open up the range beyond that. Now, as you get past that, the quality of data is going to drop. And so we're looking at those trade-offs right now. My tendency is to push forward and expose as much as we can. And hey, there's a slightly different noise characteristic at a different length. The maximum range that you could get to, in theory, not worrying about physics really, is something like 15 meters, 16 meters. But we're only pumping out a certain amount of light. And so depending on the level of ambient light, you'll get different noise characteristics as you start to get further away, because a smaller and smaller percentage of the illumination on an object is coming from our camera. Even if we expand out depth, the individual techs that leverage depth, things like skeletal tracking, will still probably be clamped to that 4.5 meter region.
Is the V2 hand gesture detection good enough to read and maybe teach ASL or something like that?
Even on the V1 sensor, there are people who have successfully done ASL translation and recognition. So certainly it is possible. The hand state stuff that we're doing in the SDK that's just baked in isn't trying to recognize like hand pose. It's not doing skeletal tracking for hands. It's recognizing between 3 very distinct states. But given that it was possible on V1 and V2 is significantly better, I'm sure it's possible and will be easier on V2. My guess is that V2 will allow the people who were doing that kind of thing before to do it at further away distances. Before, you had to be relatively close to the sensor to be able to get the level of resolution you needed to track those states.
Can you have multiple sensors in a room?
So the question is, can you have multiple sensors in the same room? And you absolutely can. If they're pointing at exactly the same space, they have the risk of interfering with each other some of the time. But it tends to be frames here and there, not as a consistent problem. And it's something where we are looking at making it better in various ways. But if they're non-overlapping spaces, there's no concern. And we see actually a lot of people who do these large installations where they're tiling space with a series of Kinects so that they can stitch together a large environment, which is all pulled into one 3D environment to do interesting things that are in larger spaces than just a living room.
Will it be firmware patches provided by Microsoft? For example, the selfies, Microsoft provides firmware patches to get us find a way to improve something.
Yeah, so the question was, will there be firmware patches if we found a way to improve something? And it is possible for us to do field updating of firmware. And so if there was the necessity to do that, to do a feature that we wanted, then we would provide those patches. The people in our dev kit preview program today get a firmware update tool that is updating each time as we're going to new builds.
If I want to build a single app or a single game across Xbox One and Windows, will I have to work with the 2 versions of Kinect differently?
Basically no. The core capabilities are the same, and we have a strong commitment to API compatibility between the places. So there will be some port effort required, but we expect that it will be very, very low. In the context of the Kinect APIs, the vast majority of them, the only difference that we expect to see is a namespace change. So it's effectively one set of if-defs and your app should function. We're also working closely with Unity. And if you use the Unity plugins, we actually encapsulate all of the changes, and it should just cross-compile. So, yep.
With the API that you're going to be releasing, is it going to support both versions, and so that like your Metro apps could be open?
So unfortunately, no. It's separate APIs, and the V2 API will not work against the V1 sensor. Certainly, we think the sky is the future. We're really excited about people building apps on them. The APIs are reasonably similar. So particularly if you were building in C#, we've heard from most customers that it's a port effort of a day, day and a half, 2 days to go from the V1 API to the V2. But there are no current plans to bring the V1 sensor into Metro. Sure. Yeah, so 2 points. One, where we just had or about to have. Just went up a blog post that's announcing all of the Kinect for Windows news for Build. We encourage people to go read that. Second point, please do stop by our booth. We'll have several people there the whole time. We have a couple of really cool partners there that have apps that people can play around with as well. Xbox machines already run Windows. Yeah, so the question was, will Microsoft allow running Windows on Xbox machines? I don't know. I don't know the right answer there. I know the core of the operating system is the same, and that over time we're going towards a world where Xbox is more open, where more people can develop for it, and there have already been announcements around that. I can say that for people who are interested in that, getting and want to build a Kinect style thing that is ultimately coming into Xbox. Yeah, I don't know the right answer to that question. But for people who do ultimately want to build an app that targets Xbox, starting on Windows is a really easy place to start. And as mentioned, apps are getting towards very portable, light port effort required, super easy development environment on Windows. So people can download the SDK for 1.8 today and get started. Most of the same core concepts are there. If you just search for Kinect for Windows SDK, 1.8 is the most recent version. It's freely available for download. That one does work with the Kinect for Xbox sensor for development purposes. And those guys have USB connectors on them, so super easy to get started there. And the Kinect for Windows V1 sensors are available for sale on Amazon or in any Microsoft store. You won't see them if you go into the store, but if you ask them, they've got them in the back because it's a developer offering. It's not yet targeted at consumers. So first, I'm sorry to hear that it was a pain. Second, it will probably be the same supplier, similar supply chain, and so. But if you're having problems getting it in a particular region, let us know. Sometimes things happen. We can work through it if we know about it. It won't be US only. I don't remember the list of countries that it'll be first. Different countries have different lead times on things like trade and custom and certifications, and so when you do these, you either make everybody wait for the slowest one, or you do it in stages. We'll choose to do it in stages. My guess is the Intel Galileo board doesn't have a DX11 compatible GPU on it, but I don't know. I haven't looked at it. If the Galileo board had a USB 3 controller and one of the Haswell chips or something, then I would actually expect it would work. But it's not something I have any knowledge around. I look forward to playing with those things, but I haven't played with them yet. So you need a USB 3 controller, which most PCs have now. We've tested across a series of them. We can share information about which ones we've tested and work well. And you need DirectX 11 compatible hardware. It works fine on a Surface, so it works on an HD 4000. Think about it, on Xbox, it takes a tiny, tiny, tiny bit of a really big GPU. It turns out it functions on relatively low-end GPUs. And we're continuing to make significant performance improvements there. And aside from the addition of USB 3 and the graphics card, the base computer requirements haven't changed. So the V1 requirements are consistent with our V2 requirements. Oh, the difference between this one and the one of these that said Kinect or said Xbox. There are a series of small differences, largely related to USB 3 or USB 2 compatibility stuff. Again, it was a case where one was built to work with one very specific card that was in the Xbox, and it behaved poorly when near other devices in terms of when it actually is connecting in. There was signal inrush. So all of that stuff, the due diligence that you do for a hardware device that is expected to connect to a broad range of hardware leads to a series of changes. Those are the kinds of changes that we had. The other significant one was in the V1 sensor. We had a near mode that we added later, which was a change in the way the laser would work. So you're depowering the laser so it's emitting less light so that you could actually see objects that are closer. Those are the two big significant differences between the Kinect for Xbox and Kinect for Windows in the V1 timeframe. You asked for the Kinect for Windows device. Sweet. I'll be around, but I think we're at time. I'll be around here and then down in our booth afterwards. I encourage anybody to either come up and talk or head down and talk.